So hi techies, welcome back to the channel. In this video, we will be discussing about what are transformers. Actually, I recorded this video earlier also, but the voice was not in that, so I am again recording this video. So let's start. So basically, transformer are a type of neural network architecture that has become the foundation of modern artificial intelligence, especially for language models like ChatGPT. They were introduced in 2017 paper. Attention is all you need. Okay, so the key idea behind our transformers is attention. Instead of processing words one at a time like older recurrent neural networks, transformer look at all the words in a sentence simultaneously and learn which one are most important for understanding each word. For example, so yeah, so basically um, you must be like wondering if you have ever wondered how ChatGPT answers questions, like how Google Translate works or how AI writes code, then you have actually asking about one of the biggest breakthrough in artificial intelligence, the transformer architecture. Before transformers, AI struggled to understand long sentences and complex relationships between words. Today, almost every state-of-the-art AI model uses transformer. So in this video, we will learn transformers from scratch without assuming any prior knowledge. Okay, so first, what is a transformer? So a transformer is a deep learning architecture introduced by researchers at Google in 2017. It was presented in the paper Attention is All You Need. I have written it over here. The main purpose of the transformer is to understand relationship between words using something called attention. Unlike older models, transformer don't read text one at a time. Instead, they just read the entire sentence together. Example, I love machine learning. Transformer look at it, I love machine learning all at once. This makes the training much faster. Now, why were transformers invented? So basically, I would explain you this with the help of RNN. If I write, hello, my name is Ayush. Problem one, it is, so how does RNN will read it? RNN reads one word after another. Problem one, it is slow. Problem two, forgets earlier word. Example, the movie that I watched yesterday with my friends were amazing. When predicting amazing, the model may forget movie. That is the thing. Okay. Now I will explain LSTM. LSTM solved memory problems. Still, sentence must be processed sequentially, still slow, still difficult for very long documents. Transformers solved this. Entire sentence processed simultaneously. Now comes the attention mechanism. You can say that attention mechanism is the heart of transformers. Suppose if I take a sentence, the animal didn't cross the road because it was tired. Question, who is tired, road or animal? Transformer will give more attention to animal. How? You can see on the screen. Mainly it focus on the word animal. Attention tells the model what word should I focus on. Okay. Now comes the self-attention. Basically, there is a, if I say a sentence, I love machine learning, Python will see it as it will give attention to I, 10%, love 20%, learning 60%, and Python 10%. Uh, okay, so highest attention is given to learning because learning Python are strongly related. Next, we have, so every word creates query key value vectors. This is very important, and you can say the query key value is the most important section in transformer. Example, you have a Google search. Every word creates a query. What I am looking for is the key. What information do I contain is the value. And here I have also written the formula for attention. Okay, next come is our multi-head attention. So instead of one attention, transformer uses many attentions. Example, if you take the sentence, the little boy kicked the football. Head 1, focus would be on boy. Head 2, the focus on will be on football, and head 3, the focus will be on kicked. All information are combined. This makes understanding much richer. Next come our positional encoding. So you can say that if I take 3 words in a sentence, dog bites man and man bites dog. Now these contain the same number of words, so how will the transformer understand? Basically, it would do the positional encoding. Same word, different meaning. It would see that. And it basically will store the location information. So transformer do that also. Now comes the encoder and decoder. I will tell you first, you can see on the screen the hierarchy of encoder. First we have the input sentence, then we have the encoder, then we have the context, then we have the decoder, and then finally we have the output statement. So what does the encoder do? Encoder basically understands the input, and what does the decoder do is generate the output. So now you have the encoder architecture in front of you. What you have, first we get an input inside encoder. You can see that first we get an input, then we have the embedding, then we have the positional encoding, then we have multi head attention, then we do add and normalize, feed forward network, and again we do add and normalize, and then we get the output. These go in the pair of like multiple of 6 times or 12 times. Next we have the decoder architecture. Basically one more layer is a block is added, which is mask multi-head attention. So basically, example, if a sentence generate I am learning, while predicting learning, model shouldn't know Python. Like if a sentence is I am learning Python, the model should not know the word Python until it reaches there. Okay, now comes the training process. So when we work with huge data set, we have billions of sentences. Objective is just one, predict next word. Example, machine learning is expected words are awesome, powerful, interesting. Model basically updates weights, repeats billions of time. Now, next we will come to applications of transformer. First and foremost is ChatGPT, then we have Google Translate, then we have Gemini, then we have Claude, then we have BERT, then we have GPT, then we have Llama, then we have recommendation system, then we have medical AI, then we have document search, then we have OCR, then we have image captioning, speech recognition, code generation. How to install transformer? Very easy, pip install transformer. And how to import from transformers, import pipeline. Okay, so basically this was it. And if I like to conclude today, so today we learned how transformers change artificial intelligence forever. We covered the motivation behind them, attention and self-attention, query key value, multi-head attention, positional encoding, encoder and decoder architecture, popular models like BERT and GPT, and finally how to use Hugging Face Transformer library in Python. So if you enjoyed the tutorial, subscribe to the channel and let me know in the comments which AI or machine learning topics you would like to learn next. Thank you everyone.